Now, so this is the perfect opportunity to go over again what I'm doing. I have two equations, so they form two lines. I have three columns. The X column, the Y column, and the number column, the constant column. And I add them together. Here, I don't have to do anything to the lines, for those of you who have a vague memory of using the elimination method, because I'm going to have 1x plus negative 1x when I add these two columns together. 1x plus negative 1x, or if you prefer, 1x minus 1x, is 0. Meanwhile, 3y plus 9y is 12y. And 11 plus 25 is 36. Which leaves us with 12y equals 36. And then to solve for y, I divide both sides by 12. The 12s over here cancel, which is why I did it. And so I'm going to have y equals 36 divided by 12 is 3. Notice I left the answers in here, so I can check myself and we can check ourselves. Now, solve by the elimination method means solve the system. So something we said on Tuesday is that solving a system of straight lines means that, well, here's one line, and here's the other line. As it is, look at their slopes. They are indeed perpendicular, but they don't have to be. All they have to do is cross. Where the two lines cross is called the solution of the system. And it is a point. It's the point at which the two lines cross. And so it is going to have an X coordinate and it's going to have a Y coordinate. Well, I have just found the Y coordinate. Y equals 3. But I still have to find X. I can now go back and use either one of these equations to find what X equals, and no fair looking at the answer. All right, I can use row 1 or I can use row 2, might as well use row 1. X plus 3y equals 11. Well, I just got the answer y equals 3, so I'm going to put a 3 right here. X plus 3 times 3 equals 11. Well, 3 times 3 is 9, so X plus 9 is 11. And to solve for X, I subtract 9 from both sides of the equation. 9 minus 9 is 0, or 9 plus negative 9 is 0. So X equals 2, and indeed, we have just found out what the X coordinate is. And that is basically how you use elimination to solve a system of linear equations. In other words, straight lines. To find the point of intersection of two straight lines. we move on. Unless there's a question about this. Do you have any questions? Okay, then we move on. Notice I wasn't sure how many steps this would take, so I gave each problem a whole page. I think I did anyway. Okay, now I want to add those two lines together so that I can find where they cross, and these, incidentally, are going to look something like this and that. And they're going to cross at something like this. Just doing a quick calculation in my head. But, all right, this is row 1. This is row 2. And column 1, column 2, column 3. And all I have to remember to do is put the X's in the same column, the Y's in the same column, and the constants, the pure numbers, in the same column on the other side of the equal sign. This is what standard form is primarily used for, solving systems of linear equations. So again, I'm going to add these guys together because I can see that 2y plus negative 2y, or if you prefer, same thing, 2y minus 2y is 0. Well, that zeroes out my y terms, which means I'm going to be solving for my x terms. Cool as grits. 7x plus 4x is 11x equals. Now this is negative 31 plus negative 46, and when you add two numbers, you just add the numbers. 1 plus 6 is 7, and 3 plus 4 is 7, and because they're both negative, the answer is going to be negative. That's the rule for addition. All right, 11x plus 0 is 11x. 11x equals negative 77. Water. Okay. Now to solve for x, I divide by 11. The 11s cancel out, leaving me with x on the left. And on the right, I have negative 77 divided by 11, and that's negative 7. So x is negative 7, and that agrees with this. Thank goodness. So I know that my x coordinate is going to be negative 7. Now I have to find the y coordinate. Now that I have a number for x, I can use either line. And they both look equally easy. I'm going to use row 2 just because I used row 1 before, but it doesn't matter. Okay. So 4x minus 2y equals negative 46. Now, I'm saying that x equals negative 7. So this is going to be 4 times negative 7 minus 2y equals negative 46. 4 times 7 is 28, So positive 4 times negative 7 is negative 28 minus 2y, which is the same thing as negative 2y, equals negative 46. Now I want to solve for this term, and that number takes the sign in front of it. So here I have negative 28, and I can zero that out if I add positive 28 to it, which is the whole reason I do this. So that I will have 0 here minus 2y. We'll kind of go back to the beginning of why we do that. It cannot hurt to review. And I'm going to scroll up. Okay, well, 0 minus 2y is negative 2y.
Aren't we supposed to add 28 to the 46 too?
Yes, we haven't done it yet. Thank you. Plus 28. Okay, so, yeah. So we're going to have, yeah. I'm going to pull out the calculator. Come on, there. Negative, notice I hit the negative button, negative 46 plus 28, enter, is negative 18. So negative 2y equals negative 18. I divide by negative 2 and divide by negative 2. So the negatives cancel, the 2's cancel, leaving me with a y. Y equals 18 divided by 2 is 9. Negative 18 divided by negative 2 is still positive 9. So y equals 9. Let's see. Yes, okay. All right. That's a good reason to not go off on a tangent when you've only added 28 to both sides. I should have waited till I had added it to both sides, then come back. Something to keep in mind. But first, whoop, here we have the point where these two lines intersect. This is used a lot in the trucking industry. This is the beginning, the very beginning of logistics, which is a gigantic field. Amazon uses it, shipping, well, Amazon is a shipping company as well as a wholesaler. Well, it's not a wholesaler, it's also a retailer. J.B. Hunt uses it. The military uses it. This is the very beginning of logistics. You might want to consider taking a logistics course when you're done with this course. Our community college actually has a degree in logistics, and most community colleges don't. But logistics is a very marketable field. Just say it. Okay. Now here we have another system. Notice it's not X and Y. I can live with it. Let's see if we have a whole page. Yes, we do. Okay. So what I'm going to do is come down here. 7r minus 3s equals 23. S's are very dangerous. They look like 5s. So you have to be careful to try to make it look like an S. 2r minus 6s equals negative 14. Now notice, we can't just add the two lines together like we did before, and one of the variables will automatically cancel out. Incidentally, what we've done up here, before we go on, what we've done in this problem, we could add the two lines together, but we'd have 2y minus 2y, and that would give us 0. And up here, we would have 1x minus 1x, and that would just automatically give us 0. These are called row operations. Okay, and the first row operation, row op 1, is adding the two lines together. Now we're going to use another row op. I have to add the two lines together and make either the R's or the S's cancel out, 0 out. That is, I add them together and they equal 0. It's not going to happen right now. So I have to come up with something we call a recipe. Okay, this is row 1, and this is row 2. And I'm going to show you how I would do it. You don't have to do it my way. You could do it another way. If I want to, oh, absolutely, never mind. You always want to find the easiest way. Always go for the easiest way. Now, if I want to be, well, first, what do I know? What do I know? Looking at this, I know immediately that 2 times 3 equals 6. So forgetting the signs for a minute, 2 times 3 is 6. All I would have to do is multiply this line by 2 to get a 6 there. It's not going to be quite that simple, but close to that simple. Now what I want, I mean, that would be really super easy. I want to be able to say 6 minus 6. But that's not going to work here. If I could make this into a 6 by multiplying by 2, I would still have to change one of these signs. And there are a couple of different ways I could do that. So the easiest way, I think, but maybe not for you, would be to do this. Here's my recipe. I am going to multiply the R row, well, let's just say row 1. I am going to multiply row 1 by negative 2. Okay, and then I'm just going to add it to R2 with no changes. Now, some calculators that you do this on with a program called row ops that you'll use if you go on to finite math. The row ops, or some versions of the row ops program, insist that you put a 1 in front of row 2. Now, R stands for row here, and I'm not talking about the R's. But notice I am talking about multiplying the entire row 1, by -2. Okay? This is what I'll get if I do it this way. -2 times row 1 will give me -2 times +7 is -14R. -2 times -3 is +6. And that's going to be the S term, so +6S. And -2 times 23 is going to equal -46. That's what happens when I multiply the entire equation up here in row 1 by -2. Now, if I want to just add that to 1 times row 2, then that will be 2R minus 6S equals -14. And notice that what we get from that is this. First, what I wanted, 6x minus 6x zeroes out. So I'm left with -14R plus 2R. Since -14 plus 2 is -12, I'll have -12R equals 6 plus 4 is 10. Carry the 1. If I'm ignoring the negative signs, 1 plus 4 is 5 plus 1 is 6. So -46 plus -14 is -60. Or you can put it in your calculator. -14 plus -46. Enter. That's -60. Or if you wanted to say -46 minus 14, that would give you the same answer. So you have some choices. Thank you. Okay, so to solve for this, I would divide to solve for R. I would divide by -12 and divide by -12. The negatives cancel, the 12s cancel, leaving me with R, and then equals -60 divided by -12 is +5. And so R equals 5. Let's double check. You can also say -60 divided by -12. And then hit enter. But look what happens if you forget and do this. -60 divided by -12 or divided by -12. Well, we'll do that next. See, you got the wrong answer because of that. That answer took the 5 in and blah, 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 blah. Yeah. Okay, so I don't know how it got 10. All right, negative. Now, here's what I'm going to do. Let me clear everything. Minus, nah, this is hopeless. Second, quit. Minus, no, it's not going to work. Minus 60, but divided by minus 12. Error. The number one cause of an error with this calculator or any calculator is hitting the minus key instead of the negative key or the negative key instead of a minus key. So be aware of that. Now, I just solved for r equals 5, but let me show you this. Suppose it didn't occur to you to do this. Suppose, this is suppose, and it's not wrong. Suppose you wanted to multiply row 1 by positive 2, and then add that to negative 1 times row 2. What would that do? Well, let's see. 2 times row 1, let me roll this down a little bit. 2 times row 1 is going to equal 2 times 7r, which is 14r. And 2 times negative 3s, or minus 3s, which is minus 6s, equals 2 times 46. 2 times 23, which is 46. Now, negative 1 times row 2 is going to be negative 1 times 2r is negative 2r, and negative 1 times negative 6s is going to be positive or plus 6s, and negative 1 times negative 14 is positive 14. So 14 minus 2 is 12. So 14r minus 2r is 12r. Negative 6x plus 6x is 0. And 46 plus 14 is 60. So you have positive 12r equals positive 60. Divide by 12, divide by 12, and you get r equals 5. And it looks to me like this would have been easier to deal with. So this actually would have been the better way, but you get the same answer with both methods. Now that you have an answer, either way, you can go back to either equation and substitute 5 for r. Right, so this is going to be 10 minus 6s equals negative 14. And if I subtract 10, well, let's add a negative 10. And subtract 10, now let's add a negative 10, what the heck? Negative 10 plus 10 is 0. So you're left with negative 6s equals negative 24. divide by -6, divide by -6. What did I do? Oh, that's right. Duh. The negatives cancel, the 6's cancel, leaving me with S equals, and -24 divided by -6 is 4. So we have R equals 5 and S equals 4. So there they are assuming that just like R comes before S, well, that's just like X coming before Y. So they just put the points together, and instead of XY, they call it RS. And so you still have a point, and you still have 2 lines, but you would graph them on the RS axes, which are acting just like the X and the Y. Now, I need to check on something. Aha! I want to do this problem an entirely different way, so I'm going to insert a page right here. And there should be a blank page over here. Good. Now I went for the easier way, but it's not the most interesting way to solve this. So let us move this down there so I don't have to be flipping back and forth. Okay. Now I'll go back up. Well, this is row 1, and this is row 2. And what would happen if I had decided to eliminate the R's first? I just wanted to do it. Nothing is going to stop me. So let's put down that that's what I want to do. Eliminate the R's first. Why? Because I decide to do it. I just decide to do it. This is what I would have to think. Well, how do I make 7R and 2R be something R, well, no, something R minus something R? What is the easiest, quickest way? And here's what I know. What do I know? What I know. Because you carry your knowledge with you. You know probably that 2 times 7 equals 14. And that 7 times 2 equals 14. All right, you're going to get a positive 14 and a positive 14 if you multiply this row by 2 and this row by 7. But what if I divide this row by negative 7? Then I'll have negative 14. And then 14 minus 14 would be 0. So doggone it, that's the way I want to do it. Nobody's going to talk me out of it. But you see, it's a little more difficult, but so what? Going to say 2 times R1, row 1, minus 7 times row 2. This is my recipe. Forgot to write that. Okay, so here we go. I am going to find 2 times row 1 and negative 7 times row, not squared, you silly goose, 2. Cool. That means I'll take 2 times 7R minus 3S equals 23. And then minus 7 times 2R minus 6S equals negative 14. Now that's harder. I could have, no, never mind. I could have made negative 2 up there and positive 7 down here. It really wouldn't have been that much easier though. Okay, so let's just do it. This will be 2 times 7R, 2 times minus 6S, and 2 times, that is 2 times minus 3S, and 2 times 23. So that will be 14R minus 6S equals 46. And negative 7 times 2R, negative 7 times minus 6S, negative 7 times negative 14. All right, negative 7 times 2R is negative 14R. Negative 7 times negative 6S is positive 42S. And negative 7 times negative 14, 7 times 4 is 28. 7 times 1 is 7 plus 2 is 9. Let's make sure. Negative 7 times negative 14. Enter. Yeah, all right. Now, 14 minus 14 is 0, so 14R minus 14R is 0. Negative 6S plus 42S is the same thing as 42 minus 6. 12 minus 6 is 6. And the 4 becomes a 3. But if you feel insecure, that's what these guys, calculators, are for. Negative 6 plus 42, enter, is 36. And while I'm here, 46 plus 98, enter, is 144. So we're going to have 36s equals 144. And then to get s, you're going to divide by 36 on both sides. 36 divided by 36 is s. Well, cancels out and leaves you s. And 144 divided by 36 is 4. So we're getting the same answers we got before, but in the opposite order. Here we found R first. Here we're finding S first, and S is 4. Now that I have S equals 4, I can go to either one of these equations and stick a 4 in for S. Either one. Let's use row 1 this time. I think I used row 2 before. Yeah, let's use row 1. For no particular reason, except I've chosen to do things the harder way. So, if I use 7R minus 3S, and I'm thinking S is 4, equals positive 23, 7R minus 12 equals 43, equals 23. Why did I do that? I don't want to do that. Habit. What I want to do is I want to solve for R. So I'm going to add 12 to both sides of the equation. Negative 12 plus 12 is 0. So I've got 7R equals 3 plus 2 is 5. 2 plus 1 is 3. 35. Then I divide both sides by 7 and by 7 so that R equals 5. And that is what I got before also. So you don't have to always look for the easiest way. I know people who decide, I'm always going to get rid of the first term first. I'm going to eliminate the first term first, no matter what. Okay, whatever. Okay. Now, we're about to move on to word problems. Is there anything I can answer about these 3? Okay. All right. I haven't worked these in advance, so you're going to have to work these for me. A woman bought some large frames for $19 each. I'm going to underline these. Large frames for $19 each. And small frames for $5 each. Now always take notes when you do a word problem, okay? Here's what I know. Large frames, large, are $19 each. And small frames, must be a lot smaller, are $5 each. She wants some frames. Maybe she has a bunch of pictures of her family. Okay, she bought 26 frames. So I'm taking notes here. Total. Total frames. $26. And total money. $242. This lady really wanted some frames. I bet she's sending Christmas presents. That would make sense. Okay, so now here, notice that there's 2 of each. What I'm going to do is this. If just because I'm used to X and Y, I'm going to let X equal the number of large frames that the lady buys. And I'm going to let Y equal the number of small frames that the lady buys. And that will mean that if I add the large frames and the small frames that she buys together, that'll be 26, because it says so right there. Now, the money she spent on them would be $19 for each large frame. So the total amount of money she spends on large frames is 19 times X. And the total amount of money she spends on small frames would be $5 each times Y. And we're told that the total amount of money is $242. Well, we have 2 equations in what we call 2 unknowns. That is, I don't know what X is and I don't know what Y is, and I'm not looking at the answers. I'm not supposed to know. So we'll roll it on up. Now, if you remember substitution, you could certainly use that here. But we're being asked to use elimination. So I could, here's what I could do. If this is row 1, and this is row 2, then I could multiply row 1 by -19 and add it to row 2. But 19, I would have to multiply it by 26. I'd have to go to the calculator. I don't wanna. So 5 is a whole lot better, don't you think? Easier. If I were to multiply row 1 by -5, and then add it to 1 times row 2, this is what I would get. I would get -5x plus -5y, which is -5y, and that would equal 5 times 6 is 30, carry the 3. 5 times 2 is 10, plus 3 is 13, and negative times positive is negative. So that's how I would temporarily be changing R1 negative 5, negative 5, negative 5. And now 1 times row 2 will give me 19x plus 5y equals 242. And now, negative 5x plus 19x is the same thing as 19 minus 5, which is 14. This is 0. Negative 5y plus 5y is 0, which is the whole reason I did it. And now, 2 minus 0 is 2, 4 minus 3 is 1, and 2 minus 1 is 1. But let's make absolutely sure. Negative 130 plus 242 is 112. And while I'm at it, negative 5 times 26 is negative 130. Yay. Okay, just making sure. Okay, now I'm going to divide by 14. And I'm going to divide by 14. So, calculator, come on back. 112 divided by 14 is 8. So X, the large frames, equals 8. So let us assume that the lady bought 8 large frames, and then I'll go look. But I seem to remember 8 being the first number. Notice that when these are word problems, we don't, I know, depending on the problem, we don't necessarily write it like that, because it really wouldn't make any sense. Well, yeah, you could stretch it, but yeah, word problems tend to be like this. Okay, now that I have a number, I can go to either of the original equations. They have to be the original equations. So, for sure, row 1 looks easiest. X plus y equals 26. So, if X is 8, I'll have 8 plus y equals 26. And I won't divide anything. I'll subtract 8 from both sides. (16 minus 8 is 8. 2 becomes a 1. Bring that down. Y equals 18. Easier to do on the calculator. But yes, she bought 18 small frames, and so Y equals 18 is 18 small frames. So if your spouse or partner goes out and spends a whole lot of money getting 2 things, you can figure out how many of each one they bought. Okay, so you have to read the words really easily, and I find it easier to take notes as I go along with what we're being told. The large frames are $19 each. The small frames are $5 each. The total frames are 26, and the total amount of money is 242. Just seeing it there in writing, my writing, helps me figure it out more easily. You want to discuss this? Okay. A basketball player scored 19 times. "19 times in one game. He scored a total of 27 points. Oh, he scored 19 times. He scored a total of 27 points. 2 for each 2-point shot. And 1 for each free throw. How many 2-point shots did he make, and how many free throws? This is hard. Harder. Okay, so a total scores. "19 times. Now, he scored a total of 27 points. Total points. "27. Oh, Lord. 2 for each 2-point shot. And 1 point for each free throw. All right. Well. All right, let's go easily and slowly on this. Okay, if I'm going to actually go to the trouble of writing let. Number of 2-point shots. And y equal the number of 1-point shots or free throws. Okay, each x equals 2 and each y equals 1. Good grief. Well, let's just go to basics here. The total number of scores in the game by this person think I'm making it too hard. Now these are the scores, or the number of times he scored. Let's say scored. And total number of points, 2 for each of these, and 1 for each of these, equals 27. It's not that bad. But it's written in a way that's kind of confusing. Maybe it's not. A basketball player scored 19 times during a game. Put-a-boom. 1. Put-a-boom. 2. Put-a-boom. 3. Okay. He scored a total of 27 points. Yeah, okay. I was making it too hard. 2 for each 2 shot, and 1 for each 1 shot. 1 point. 2 for each 2-pointer, and 1 for each 1-pointer, which are free throws. So, yeah, this is all we need right here. This is based on the amount of information given. And I was adding this in thinking, oh my gosh, do I have to have another row? Blah, 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 blah. No. Okay. So, now we can use elimination. How about this 1y? How about them 1y's? Suppose, now that I've got this, okay. If I think the easiest way is just to multiply -1 times R1 and then +1 times R2. So -1 times R1 is going to be -x minus y equals -19. And then 1 times row 2 is going to be 2x plus 1y equals 27. Okay, so if I add these, -1x plus 2y is 1x, which of course is just x, and -y is the same thing as -1y. -1y plus 1y is 0. Goodbye. And -19 plus 27 is +8. I think, but I'm going to get the calculator on that. -19 plus 27, enter. Yeah, okay. So x equals 8. 8 is the number of 2-point shots. Now, we have to solve for y, and absolutely this first equation is the easiest one to use. X plus y equals 19. X is 8. 8 plus y equals 19. Minus 8, minus 8. So y equals 11. Doesn't look familiar. Ah, but it is. Okay. Yeah, the 2 shots and the 1 shot, that was like added information. But we needed it. Yeah, okay. Discussion about this. We've only got 5 minutes. Oh, that's it. Okay. Well then, I am going to save this before I do anything else. And I'm about to put that in the wrong class because we're in COREC. So there you go. Yep. Yep. Oh, right. Go work on these over the weekend. On Monday, we moved to bigger systems. These were 2 by 3. On Monday, we moved to 3 by 4, which is 3-dimensional in real life. We're not flat characters on a whiteboard. We're 3-dimensional people. So, yeah, Monday, we're going to be dealing with the variables X, Y, and Z. And you're going to learn about not only is there an X-axis and a Y-axis, but there is a Z-axis. All right, if this is the Y-axis and this is the X-axis, the Z-axis comes right out at you. So we'll talk more about that. For those of you who have been in the military or are just familiar with GPS, this is where we start doing latitude, longitude, altitude. Real life stuff. So, if there are questions, please stay behind. Otherwise, you are free to go.
Have a nice day.
Pardon me?
Have a nice day.
Oh, thank you. You have a nice day and a nice weekend.
Have a nice rest of the week.
Yes, you too.